Okay, so welcome to our monthly Tech Tuesdays Demo and Discuss, a monthly meetup for technology educators to share info about trending projects and practices. We've been doing this, well, I've been doing this with AET for, I don't know, Kristen, what, like a year and a half now?
Yeah.
And yeah, it's been really fun. This month we are talking about waterjet cutting, and we're going to talk a little bit about the applications of the waterjet system that AET offers, and look at the workflow a bit more closely. So before we get started, let's just take a quick look at just a handful of waterjet cutting applications. So if you're not familiar, the waterjet, like in its basic form, a waterjet cut is produced by jetting a fine stream of water that is mixed with an abrasive mineral, usually in the system that we sell, which is the ProtoMAX. It's a garnet abrasive that it gets fused with. And this machine is used widely in industries like stone countertop making, because it can easily cut through stone and cut through a very thick mass of stone. A big benefit to waterjet cutting is that it doesn't produce heat in the same way that like a laser cutter or another machine like a mill or a table saw would. So it has a very broad spectrum of materials it can be used with. Some waterjet cutters have a third axis. In most cases, a waterjet cutter just works on a 2-axis XY plane and jets out to cut a flat surface. And some of them have a third axis that allows the tool to tilt on its side, which is what you're seeing in this image in the bottom right, in order to make something like a turbine, a metal turbine. Waterjet's also used in food preparation, like mass production and getting, different types of foods cut down to size for packaging. Resource management solutions. What we're looking at here is, it's kind of tough to tell, but these items are sitting on a pallet, and these are actually like large pipe fixtures that would then have valves associated with them. Aerospace components. And if you were to ask me, I couldn't tell you what these components would be used for, but they look like they would be something structural, maybe having to do with like the housing around like a rocket platform, or maybe an actual satellite or something to that effect, but definitely used in producing parts like this that are very, very thick. So it's tough to tell in the background, but there's an OMAX waterjet system in the back of the image. So we're looking at these cut pieces are probably like 6 inches thick, maybe 5 or 6 inches thick. And then another interesting application is fine jewelry. In this case, I think this is Damascus steel, and the creator of this ring here, which is like a typical size of like a ring finger ring. A piece of bar stock was cut off horizontally and then flipped in order to cut out the center hole, and then of course they go through the finishing process after that. So it's a pretty impressive that they're making fine jewelry this way too. If you click on the link, learn about waterjets, OMAX Waterjet in the bottom, it should bring you to the OMAX website, and they have tons of information on applications, case studies, people that are using OMAX Waterjet products. So it's a great place to learn more about applications and about waterjet cutting in general. Since we have a demo ProtoMAX Waterjet Cutter in our demo lab. We have used it for some projects, and before we take a look at some of those, the first one I want to share is from a customer of ours, which is a teacher at Justin, you might have to help me with the pronunciation, but New Canaan High School.
New Canaan High School.
Thanks, Justin. So New Canaan High School in Connecticut. So this is a prototype that was cut out of acrylic that eventually would probably be cut out of metal, but the teacher was working with the students to motorize like a basic foot scooter, and probably the students designed this bracket in CAD, and then they cut it on their ProtoMAX Waterjet Cutter that we set up for them. This mounted swivel arm prototype with 3D printed assemblies is a sample project that I did just to kind of show how you can get creative with how you're assembling flat pieces cut on the Waterjet. And then we see up top custom fixtures for Vex Robotics project. These parts that are right up here were cut on our ProtoMAX, which is in the background here in our demo lab by Dave Kempsky, AET's founder. And he collaborated with a local Vex Robotics team that essentially shared a file with him for him to manufacture the parts. And they were used in this very fancy looking Vex Robotics project on the middle here.
It was First Robotics.
Oh, First Robotics. I'm sorry about that. That's my mistake. Big difference there. Yep. Thanks. And last one is very simple, but one little project I did, and this is just a little hex wrench that I cut out of I think a 1/8 inch sheet of aluminum. And we're not doing much engraving with waterjet cutting for various reasons, but this was me kind of just testing out the ability, the Waterjet's ability to engrave. All right. I think what we're going to do now is just jump into the software side of things before we take a look at a couple of other slides. And today we're specifically going to take a look at the workflow from Fusion 360, which is Autodesk CAD software. A lot of high schools and universities use this software for engineering and design, to the ProtoMAX software. Kristen, you can see my screen, correct?
Yep.
So here is a assembly that I made in Fusion 360. And it has a handful of components over here on the left. The idea here was to make a durable but very, very light product that was specifically designed for cutting on the Waterjet. And of course, if you did have a laser that could cut metal, you could use this workflow for that process as well. But typically, those lasers have a very high price tag, and the Waterjet comparably is a much cleaner and more effective solution. So what we're looking at here, I'm going to hide some of my my assemblies over here. So let's get rid of all this stuff. What we want to do is just take the profile of this part and turn it into a drawing, which if you're familiar with CAD, you may already know how to do. But in Fusion, what we can do to basically extract this, if we have a sketch already, which some of these might already be there, we could export our sketch. But what I like to do for the digital fabrication workflow is select the face of a flat 3D, or I should say a 3D object with a flat face, because then I know I'm getting exactly what I'm looking at, just in case there are any like anomalies in my original sketch that I used to make the model itself. This I know I'm getting this profile that's highlighted. So by right clicking, I can go down and click oh, I think I've already created a sketch for this. So let me back up. All right, bear with me here one moment. Something's. Oh, there we go. I would have the sketch selected, not the actual face of the model itself. So selecting the face of my component here and right clicking, I have the option to click Create Sketch. And what that does is it basically makes kind of like a singular sketch of that face. If I click Finish Sketch, I now have a sketch, a new sketch populated in my browser on the left here. So if I hide the component, I can see that I have right over here, called Sketch 2. And from here, I can right click and save as DXF. But before I do this, one thing you would want to do if you are working in Fusion 360 is I would recommend changing your units. If you're working in metric, change the units to inches, and this will make it a smoother transition to the ProtoMAX software. So from here, we're going to right click on our sketch that we just made and click Save as DXF. I'm going to save it as Profile 1 and then save. And that's it from the CAD side of things. We've made our model already. We extracted a sketch and exported it or saved it as a DXF. And now we're going to open the ProtoMAX layout software. You can go to ProtoMAX's website and download this ProtoMAX or the IntelliMax software suite by ProtoMAX for free if you want to tinker with this software. If you're looking to explore waterjet cutters and just like take a look at the workflow, it's a good way to do it. So in ProtoMAX layout, this is where we bring in our artwork or we make our own original design, and then we prepare our tool paths. After we do this, we then move over to ProtoMAX Make, which is the software that interfaces with the actual waterjet cutter. We'll take a look at that in a minute. For now, we're going to go to File, Import from Other CAD. And notice we do have Insert and Open, but we want to make sure we're importing from Other CAD because the software is designed to work with like third-party software. So it makes sure that, it ensures that we're bringing in the artwork properly. And we're clicking on Profile 1 and Open. And we have a preview right here of our sketch that we took from Fusion 360. I know that in Fusion, the length of this is a little over 8 inches total. So when I'm in ProtoMAX layout, I can see that we have our grid here, and which is each block is an inch. And also I have dimensions right up top here showing me the width, so 8.36 inches. So I know that it's actually imported the correct at the correct dimensions. You have some options over here, but we're not really going to look at those right now because we're just looking for the quick and easy way to get this ready for the waterjet cutter. So we'll click OK. And now we're in the editable interface here. This is very much kind of like 2D graphic design software where you can draw lines, curves, connect points together, attach lines to, like if I wanted to go over and click a line over here and make sure that it is snapping to another object, I can do that. But it's very easy workflow to go from CAD, your CAD software like Fusion 360 or Onshape, SolidWorks, to ProtoMAX layout. So you don't really have to do too much work in ProtoMAX layout. What our main goal is here is tool pathing. And let's take a look at what that looks like. Okay. So if I go into my my draw menu over here, toward the bottom, I have an icon called Autopath. If I click Autopath, what it does is it automatically creates a toolpath using the artwork that you supplied. And what I love about a lot of the tool pathing software, whether you're in Fusion or SolidWorks or in ProtoMAX layout, is it's often color coded. So what we're looking at here is pink is the tool path where cutting is happening. Orange is a lead in and out. So that's where the water jet starts to do a cut and then comes out of a cut. And green is called a traversal. So that's where it's moving from, between one cut to the next, and it's not actually jetting anything. So if we take a look here, our start or end points would be here and here. And it did a really, really good job of tool pathing. So if we started right here, it would first send us over to this side to cut out this little tiny hole. And you'll notice that the lead in is longer than the lead out. And there's a good reason for that. That's because when it does this lead in, it's actually moving in toward the actual path that it will be cutting. And it needs to get up to speed. So it starts, the pump turns on and it starts jetting water and abrasive. And this gives it a little bit of a lead time so it can be at its optimal point when it cuts this circle. And when it leads out, it doesn't need to be as long because it's just going to lead out and shut off before it makes a traversal. And then you'll notice that it hops over to the next area, does a cut, and continues on. So if your artwork is nice and clean and simplified and doesn't have a lot of potential errors in it, for example, it could be something like maybe you have let's see, maybe you have a second line like this that you didn't know was there, or maybe it's too close to another line and you didn't see it. The software might not deal with that very well. What's nice is we can actually use this software to detect errors like that. So let's turn this. Right now, you see I drew a line. It's green, so it means it's going to be a traversal. But I'm going to go down and click on quality. And with quality, I can choose essentially what speed the machine's running at. So the faster the speed, which would be 1, the rougher the cut. And the slower the speed, which would be 5, would be a higher quality because it's jetting more along the edge and creating a smoother edge. So you can see 3 is pink, and that's what's selected on all the lines right now. If I did 1 and clicked on the line I just drew, you can see it now assigns it the quality of 1. I'll just keep it at 3 for now. Okay. So at this point, I'm ready to actually make my toolpath, to generate my toolpath, including this little anomaly I put in there. So let's see how it does. So at this point, I can go on to the right toolbar and I can click Post. And it gives me a little icon that says Pick Start. So where is my home position? So that would be like my starting position of the job. And I'm going to start it right at the tip of this green line. And it actually looks pretty good. It looks like it actually didn't render that extra line that I drew, which is good. If it did, we'll click check for problems to see if it found anything, and it actually didn't. So yeah, it didn't even render the line, probably because it wasn't closed. It wasn't actually a closed object. So without any issues here, I would actually be good to go. But if we take a closer look, we still see all of our traversals and lead-ins and our path. But what we're looking at in kind of the maroon or dark red is the actual cutting representation that includes a kerf width of 0.015. And if you're not familiar with kerf is the cutting width of the tool, the cutting tool. So in this case, the actual width of the water jet that's cutting through the material. And of course, you could change that. So I could go in and say like, and now it's a thicker line. All right, so yeah, our toolpath is looking good here. I can click Save, and it saves to where I opened my my original file and downloads in this case, and now I have a project file that is ready to be brought over to the ProtoMAX Make software. So let's take a look at that. Adam, I'm just seeing your comment from like 9 minutes ago. Such a faster process than you were using. If you want to tell us a little bit about it, please do. So what we're looking at now is the ProtoMAX Make interface, and this is the software that it's the control software for the machine. So with this software, we can physically jog the actual tool, and we can do things like test or run the water jet, just pumping water through if we wanted to. We could go into begin machining, and if we look at the path control, actually, I'll just back up here for a second. So what I did was I clicked on begin machining, and I right click on start, and it gives us the option to do a dry run. So we don't have to jet, we can actually have the ProtoMAX lid open, and we can run the machine and see how the toolpath is gonna run without actually jetting. I'm going to back up one more time here. I just want to show you something. So I'm going to re-import our file. All right, so if I open a new file, in this case, our profile one, I just want you to show that it gives you the option to like double check your work here and click on check for collisions. And I'm going to talk to you a little bit about what a collision would be after this section. But I click on check for collisions, no potential collision areas found. Okay. In this area here, when you're importing, you also get to do some important, assign some important settings, like what material are you using? And we have a huge material list here, which is a great way to get kind of accustomed to what can a water jet be used for, like what can it cut? And you have this list is categorized as well: composite laminate, glass, metal, plastic, different types of plastic, stone, lots of stone, wood, ductile, brittle. So a lot of options here. We're doing aluminum. We're entering our thickness for aluminum, the exact thickness we have for the aluminum, which kind of dictates how fast it will machine. And then our tool offset, which is, of course, our kerf of the actual jet itself. Nothing else we need to do here. We're just choosing our material and setting our thickness. The offset with a ProtoMAX system will be set by default, but of course you can do tests and machine your own parts to determine as close as possible what is the offset, what is the actual kerf of your waterjet cutter. We'll click OK. And now we could actually go in and click Begin Machining. And we'll do a dry run at rapid traverse. Now, of course, when I click Start, nothing happens because I'm at home, not connected to a waterjet cutter. But if we did run the waterjet cutter, we can see a quick little demo of what that would look like. So I'm going to bring my PowerPoint presentation back up here, and we'll take a look at a short video. Okay, Kristen, is this up for you?
Mm-hmm, yep.
Thank you. Okay, so yeah, we're looking at like a little inside view of our demo ProtoMAX. So when this is actually the end of a cut. So this was, I think, a smaller, you'll see the part, but this was like a total of like a 2.5 or 3 minute cut. And this is sped up at 2 times the speed, the original speed. And that's me like moving the tool head out of the way. And that's that little engraved wrench I showed you earlier. So yeah, that's kind of the short version of getting something ready from Fusion 360, saving it, exporting a DXF, and bringing it over to ProtoMAX, ProtoMAX layout, and then ProtoMAX make. Since we're in the presentation here, I'm going to bring up a couple of things before we take a look back at the software. So common obstacles, and of course, when you're working with any machine tool, you always have things to consider here. But this is something common in mostly in, like, I would say, plasma cutting and waterjet cutting. Because the nozzle, which is underneath this yellow cup here, is so close to the surface of the material, if you're cutting your part and the part falls in a little bit, like this one, it says cut parts may obstruct toolpath. If your toolpath is designed in such a way where it needs to make a traversal that goes back over a part that it cut, then it very well could hit this obstruction. So that's where kind of making custom toolpaths comes into place. We'll take a look at that a little bit and how you can easily change where how your toolpath is laid out in ProtoMAX layout. The other thing with respect to editing your toolpath is this little burr that we see on the corner. So lead in, out, location, or angle may leave burrs. Does anybody on my team or Adam like to guess why this burr is here, or what might have caused that? I'll just say if you do, jump in, please. All right, so let's pop back over to the software. Okay, so back to ProtoMAX layout. So in that image that you saw before where there was a little triangle sticking up, that can happen if our toolpath, if we have a traversal. Oh, hold on, Adam typed in. I'm guessing you should overlap the path to fix that, but I'm unsure why it happened. Okay. Yeah, not necessarily overlapping the path, but what might have happened with that is that the lead in and out was actually at a on a curve. So on something like a circle, you can't really avoid that. You have to have the lead in and out happen on an arc. But you'll notice that every other location, the lead in and out is at a flat surface. One thing that might help is the angle right here of the lead in. So if we angle this a little bit more, that might help. But you're also right, Adam. You could, if you did overlap it, that might help as well. But it also could, because we're using like an abrasive, it could take out a little more of that edge as opposed to leaving a burr. It might leave a little indentation, if that makes sense. But yeah, let's take a look at how we can change that. So let's say I'm going to go in right now and go into AutoPath, and I'm going to change by right-clicking my AutoPath setup. So if I go into AutoPath Advanced and Configure, I can change all sorts of things here. I can say, like, where would my start and stop points be automatically laid out? In this case, it's laid out in the bottom left and upper left, or front left and back left. You can also change your lead in length and your lead out length. So you see here it's 0.15 inches lead in, 0.05 inches lead out. You can also change the angle. So we could go in and actually just change the angle. And let's say 2.5, I'll do 5 degrees on both of these. And you can also change the style from line to arc. But when we click arc, this is really nice. So ProtoMAX gives you a little pop-up that says it's unusual to use arc style leads for abrasive jet applications, saying that it might cause a blemish on the final part, and especially in thicker materials. And that was like when I first started using that was news, or the Waterjet, it was news to me. So we're going to keep line for now, but you certainly can change it for something thinner. You could change it to arc and see how that works. But all we changed here was the angle. So I'm going to click go. And if I right click on AutoPath, I can erase my leads and traverses to kind of reset autopathing, and then click AutoPath again. And let's zoom in, and we see it barely changed. So we have a little bit more of an angle on our lead in and out. Let's try to make it a little more drastic. Right click on AutoPath, AutoPath Advanced and Configure, and let's do angle 15 degrees. Again, I'm going to erase leads and traverses and click AutoPath. Okay, so now we're seeing we do have a little bit more of a drastic angle for the lead in and lead out. That might solve something like a burr, but if you're working with a thinner material, one thing that might more certainly solve it is, let's say if we had it on our corner here and we knew that if it were on a flat surface, we wouldn't get the burr. You can use a nifty feature over here in lead in and out. If we right click on lead in out after we autopath, we have the option to click move existing lead. And now we can actually just go in and drag our lead in and out to wherever we want on this part. You'll also note that I can reposition it too on the outside of the part. So if it's on the outside, it's going to offset. It's going to offset your kerf on the outside of your object as opposed to the inside. Let's take a look at what that looks like. So I'll click post, choose my starting point, And now if I zoom in over here, you can see because I swapped where the lead in and out is, we now are cutting on our offset is on the outside of our object. Let's see here. Check for problems. We have possible offsets to wrong side, 1. So it actually is like, hey, I think you maybe designed this to do all of your offsets on the inside. And it's right. So it's a nice little smart feature here. So I'll click reject and close that, and I'll go in and make my edit. So again, right click on lead in and out, move existing lead, and let's switch it. But what I'm going to do here is I'm going to put it in maybe what could be a bad location for a lead in and out. And I'm going to do it right here. And let's click post and start point. Check for problems. And this is another neat feature here. Now we have possible collisions 1, and that is right over here. And it shows an arrow of where the collision could happen. So that image I showed you earlier, where there was a triangle that was kind of stuck, popped up, if my my lead out finishes right here and it just cut this part out, it's now going to traverse over the whole area of that part. And there is a potential collision in case that does get, kind of skewed or is like partly sticking out. So that's why this is actually a bad location for a lead in and out. But as we saw earlier, if I clear all of my leads and click Autopath, it actually does a good job. Oh, actually that one, I think it's still in the same location. Let's see. Oh, no, that one's okay. So yeah, so this one, yeah, because I originally moved it on this side, that's right. So now it's positioned it so it's closer to, this edge. I would say if we wanted to be even safer, in case this part fell in and was still sticking up, what we could do is go in and move existing lead, and we could actually move it right here. Yep, so it jumps over to each part nicely, and if we back to our finished part, let me just switch over here. Yep, of this mounted swivel arm. It actually did a really good job of cutting this out. Okay, that's kind of it for today. I just wanted to give you like a brief